Previous course, we have implemented a zombie attack on the player. It also allows the player to fire bullets at zombies. But since there is no progress bar, it's hard for us to intuitively feel changes in player vitality and the amount of ammunition remaining. In this case, the player interaction experience is not very good. So, this lesson, let's design one first, UI that enhances the player experience. In layman's terms, we need to design a progress bar UI. This progress bar UI contains blood and remaining bullet volume information. So the idea was to create a health bar. HP progress bar. The base color red represents the player's state of full blood. Green represents the current player's health. In the beginning, green bar covers the red bar, indicates full blood. After being attacked, the green bar gets shorter from right to left, indicates blood loss. Over time, the player's vitality is gradually restored. The green bar extends from left to right again. New UI. Named character progress. Enter open. Right-click the UI root node. Create image objects. Change the name to progress group. Represents a group of live processes. Then, modify parameter settings. Layout is set to lower left corner. The width and height are set to 200 and 15 respectively. Texture map is set to none. Because this node acts as a blood bar container. So, change its color to transparent. Continue to create a picture sub-node on the node just now. Change the name to health. Represents the player's health status when they are full of blood. Also set the layout to the lower left corner. Because the lower left corner is the basis point, the width and height are consistent with the parent node. Because of the use of image footage. So, locate the UI folder in the pre-class package. Drag to the resources folder. Select all import. Drag. Set texture map. Right-click on the health node. Create image sub-node. Current health drag to set texture map. Change the image type to filled. Drag the slider. Observe the dynamic change effect during filling. So far, the blood bar progress bar is completed. Can be used for integration. Test the change of the protagonist's vitality. But since the function of our rifle has also been basically realized, here we will directly copy the UI just now. Change the name to player progress. Indicates player progress bar. Here we go. Copy the above node. Modify node name. Used to make the remaining bullet progress bar and bullet loading progress bar. Current reload indicates the current loading progress bar. Current capacity indicates the current remaining bullet progress bar. Because when the current number of bullets remaining is 0, turn on the bullet loading progress bar. So, these two progress bars can also be used as a sub-node of the bullet progress bar. Adjust the position of the bullet progress bar. Modify its texture map. Modify current reload. The texture map and color of bullet loading progress bar. Modify current capacity. Texture map of the remaining bullet progress bar. You can drag the fill amount. Fill the bullet consumption process and reloading process. Drag current capacity fill. Make it from 1 to 0. This process is the process of ammunition consumption. The progress bar shows the number of bullets left. When the length of the green bar becomes 0, running out of bullets. At this point, the length of the blue bar should immediately become 0. Then start the reloading process. Drag current reload fill. Make it from 0 to 1. Loading is complete. The remaining ammunition volume should be full. So, the fill value of the green bar should immediately become 1. Everyone needs to understand this logic. The follow-up code is implemented according to this. Again, modify its resolution to 1920 by 1080. After making Ctrl plus S to save. Here we go. We're about to implement the control logic of the progress bar. New script character progress base. This class is the base class for all progress bars. It is inherited by the subclass. So, to design it as an abstract class, add progress bar to follow target. The camera used to shoot the progress bar. The offset of the progress bar relative to the following target. Perspective correction parameter. Progress bar group name. To use the UI in the game, UI components need to be mounted on the node. To control the progress bar, you need to get the relevant pictures corresponding to the progress bar group. Add to properties. Use protected decorations. Limit the accessibility of this class and its subclasses. In addition, our abstract class are some properties and methods common to subclasses. Extract. There are also some methods common to some subclasses, but the parent class is inconvenient to implement. Methods that require subclasses to implement each. We designed it as an abstract class. For example, the initialization of subclasses. Update operation for subclasses. Then in the onStart method, perform component initialization operations. If no camera is set up, then use the first enabled camera component. Afterwards, initialize UI components and progress bar components. And finally, call continue start. Continue to initialize related properties in subclasses. The specific implementation of this method will be completed by the subclass later. Here we go. In the update method, sync progress bar position. If the scene is loaded, can't get the camera right away, then return directly. Get the camera and then sync the target position. That is the position of the progress bar UI. Relatively consistent with the position of the following object. Let's keep this method of synchronizing targets for now. After the implementation of subclasses, then I will explain the principle to you and implement it. Here we go. Let's implement the blood volume progress bar logic. New character progress. Inherited character progress base. Override superclass method. Add a progress data source. The health point data source. Add progress configuration. That is, the UI name of the blood strip. Current health UI name. Add private attributes at the same time. Blood bar UI and current health UI. Type is image, because you have to control the changes in the progress bar at that time. Complete override method. In the continue start method, initialize the value of the relevant parameter. In the continuing update method, update HP. Individual test of blood volume progress bar. We've omitted it here. You can also leave this custom component unwritten throughout the logic, because the blood volume is not displayed separately in the end. Instead, the player progress bar is displayed in a composite progress bar. Here we go. We design a player progress bar. Create script player progress. Inherited from character progress base. Add progress bar data source. That is, the health point data source and the ammunition data source. Health point data source in character health. Ammunition data source in rifle manager. Add progress configuration, including the UI name related to the blood strip. Ammunition related UI name. Add corresponding private properties. Override continue start method. Initialization related parameters. Override the continue update method. Realize update health, ammunition, and reload time. If the HP component is not empty, the percentage of the current health points of the current life component set to the fill value of the blood strip. Same principle. Add business logic for updating ammunition. Percentage of remaining ammunition set as the fill value of the ammo progress bar. Because the current number of eggs left is a private property, so we're going to be in the rifle manager. Add the necessary get and set methods. We incidentally give other private properties. Also add get and set methods that you may need to use. Next, add the logic to update the reload time. If the rifle management component is not empty and is being reloaded, then the ratio of the current loading time to the time required to change the bomb set the loading progress bar. Notice when filling here, it should be 1 minus this ratio, because in the rifle manager, our current loading time is counting down. If the calculated filling value is less than or equal to 0, it means the ammunition is full. And finally, Integrate progress bars into the game. Because the progress bar has to follow the player. So we are on the player node. Create a new sub-node player progress. Add a custom component to this node player progress. Set the corresponding parameter value. Parameter values here. It is recommended that you copy it in the UI component. Prevent unnecessary trouble. Include goals followed by a progress bar. Here we set it as the player node. Health point data source. Set as player node. Because of the player node. Ammunition data source. Set as weapon. The name of the progress bar group. Copy from UI. Here is the progress group. Other health magazine related UI names. Just operate in the same way. Run the game. Run a test. The blood bar is always in the lower left corner. Not following the player. This is because I still have a method that has not been completed before. Open progress bar parent character progress base. One of the methods for synchronizing the target has not been written yet. The effect of this method is to synchronize the progress bar with the player. It actually is to offset the progress bar towards the player's position. The idea is to add the player world coordinates to the offset. Convert to screen coordinates relative to the camera. Then set it to the progress bar. The reason why the y value here should be set to a negative value. The reason is that when we first set up the progress bar, his reference anchor is in the lower left corner. Move up, y value decreases. Run. Find the progress bar in the lower right corner of the player. Don't worry. We can run. Adjust this offset. Then record it. After stopping operation, put this value set to a custom component on the progress bar. The specific value is adjusted according to the actual situation. It is advisable not to block the player. If the blood volume shows half, usually because when the progress bar was first designed, the filling amount set is incorrect. Run. Discover. The progress bar shows that it is normal. Real-time display of player health points and ammunition surplus. And the ammunition loading process can also be dynamically rendered. But There are still some features that have not been implemented. For example, between zombies and players, the damage effect of mutual attacks is not reflected. Also, the player's state control is not implemented. We will continue to improve the follow-up courses. You can also think about these questions after class.